Right, greetings all. Hope this finds you well as always. It's now time for the latest update from the machine shop, where we're up to and what we're on with. And the first job we've got is Brian's been in again, and I showed you one of these fittings that he made last week for the J27's gauge frames. Well, today there was a bit of a debate over what the thread actually was. So during the week, I took the fitting he machined up to Nelpeg's shed, tried it with the gauge frame fittings. It was an excellent fit on both sides. The reason we had the debate, incidentally, was due to wear in the previous fitting. The thread was that badly worn. There was some debate as to what actual pitch it was. And so anyway, I took the one he previously made. It was a lovely fit, as I'd expect from the man. And so, as a result, today he made a second one, and we've taken those both up to Nelpeg, tried them. They're a lovely fit in the gauge frame fittings. So that's the first job done, dusted, and finished. So they can just go up there out the way. And so the next job he's moved on to is doing some bits for 81360's sand valve, which we'll have a look at in a minute. Now, the problem is, this is the old valve. It sits in the top of the sand valve and is basically the main steam valve. And you can see there's quite an impressive dent in the valve seat there. So what's happened is it's closed at some stage with a hard lump of scale or something nasty in there, and that's taken that rather large lump out of the valve seat. So Brian's in the process of making another two. There's one's going to go into the valve and the other is so we've got a spare in stock. And so the next job he's got to do is, you'll see how the body of the valve here has these semicircular grooves. They're simply to allow the steam passage to go through. Well, he's got to mill those grooves in, so he's got a ball nose slot mill set up in the milling machine. He's got the dividing head set up as well. Thank you very much, and Mr. Jeffrey has now left the building. Thank you very much, Bungle. Anyway, right, so yeah, where were we? Yes, the MIC and the running shed are now locked up, and Andrew Jeffrey has gone home. For those who were wondering, if any of you were. Okay, anyway, right, sand valves, that's it. Right, sand valves, he's going to put these semicircular grooves in. So we've got a suitable cutter and the dividing head all set up, and that's the job for tomorrow. And if we just walk around here, I'll just go and have a look at the actual valve itself so we can see what it does. We've got the valve body on the bench here. Now, the way this thing works is inside the valve, there is, let me get this the right way up. Inside the valve itself, there is a cylindrical, it's a cam basically. Let me just, this is going well. Let me get that out of there. Right, it won't come out of there because it's been an awkward swine. Come on. You haven't seen this. There we go. Right, turfed it out. Right, this thing is the steam valve, but it also acts as a cam as well. Inside the body, this little brass valve thing itself rides on top of that cam. The cam is rotated to allow these drillings to line up with various ports within the valve body itself, so to communicate steam to either the leading or trailing sand guns. And as this cam rotates, it opens this little badoofa here, which inserts into this port here on the body. The bottom of the valve protrudes out of there, and that in turn rides on that cam, okay? So that's how it all works, and that's, as I said, Brian's on with making some new ones of them, okay? And so once that's sorted, that can then go back onto 136. Other bits of 136 we've got in is we've got a lot of the small motion. Now, this is in so that, first of all, it can be non-destructive tested. That is, we check it with the dye pen technique, which I'll go and show you in a minute, for examination for cracks or signs of cracking or damage or whatever. And it's also in so we can measure up all the small bushes in the combination levers initially, and then various other bits of motion will follow. We can also measure up all the pins, and these letter codes incidentally tell us what we've got. So we've got left-hand union link back, right-hand union link back, and so on and so forth. So we know exactly where all those pins are from. And then we've got the combination levers to measure up these bushes, see what's worn, see what hasn't, and then we can replace as required. Incidentally, yes, I know it's off 136, but Well, I know I said it was 136, but the rods certainly weren't built for 136. Just quite common with standards that components were often interchanged at overhauls. Plus, also anything that went through Barry scrapyard was a bit of a bitzer by the time preservationists dragged them out. So the first job is to non-destructive test the whole lot. We use a dye penetration technique for that, and Thomas Goulding's been in today and been doing a sterling job, not dye penning for me, he's also been busily painting things in red oxide primer for Sean Bowler. And so what we've got here is one of the links in the last stage of dye penetration. The first thing you've got to do is get that surface as clean as possible. There's a cleaner spray that's used for that removes any oil or grease. Then we apply this stuff, which is a dye penetrant spray, and you can see it's a red colour, okay? Now what happens is, that red, it's a very thin dye, and it soaks into any cracks or pores or whatever in the material, and it fills those holes or cracks with dye. We let that cure for about half an hour or so. We wipe the excess dye off, and we then spray on this stuff, which is a developer spray. And this is, it's basically chalk powder in an aerosol can, and it gives a white colour, okay? Now what happens is, any of the dye that's in any of those cracks or crevices, because this chalk spray is absorbent, the dye is drawn out by capillary action, and so it appears in the white spray. Now, there's no flaws in this rod to show you, unfortunately, but I can show you an idea of how it works if we look at where the number stamping is in the rod. Yes, I know it's upside down, but you can see how that number stamping has been highlighted in pink, ignoring the fingerprints that are on top of it, and that's where the chalk spray has pulled the pink colour out of that stamping, and it's appeared in it. So that's how dye penetration non-destructive testing works. And as I said, Tom's been on with that today. He's been doing a smashing job, and he's got the combination levers yet to do next week. And then once that's done, that's all finished, and he can he can move on to 76's motion or the rest of 136's. So yeah, we've got plenty to do basically. And then the last job we've got in are some rod brasses for 76 or 79. I waved a camera at these a while ago. Two of them are remetal bushes, that one and the one that's currently in the Mostana being machined, and the other two are replacement bushes. I think I said a while ago about this. We're replacing those bushes. Those are the old bushes on the left, incidentally. We're replacing them with new castings because they've actually started to work loose in the rods. And once they start to work loose, because they're a press fit in the rod, there's nothing you can do apart from basically start from scratch with the new casting. And so those have been machined up as a raw casting. White metal's been cast into them, and we're just in the process of machining them to finish size. I think when I showed these last, they hadn't been white metalled. Well, they've now had a white metal cast into them. You can see how those lovely, sharp, smart, clean brasses have got all oxidised and whatnot from the flux and from the heat. Well, that's going to clean off there, because that bush house sitting there is about a 1/16 of an inch oversized on the outside diameter. As I said in the last video, whenever these are heated, they always distort slightly. It's casting stress is being relieved. And so the last job will be to skim that to size, and so take out any eccentricity, any ovality, any distortion, and machine it to finish size. The reason I haven't machined it to finish size is, of course, if it was, and it then distorted, well, it wouldn't fit in the hole in the rod anymore, and that wouldn't be good. So the other job I've got to do is also bore that white metal out to finish size. So as I said in a couple of videos ago, we end up with a bush that's a press fit in the rod, and when pressed in, the white metaled internal diameter is a running fit on the crank pin. So that's the idea. So there's two new ones there, one remetaled one there, and one remetaled one in the lathe. So as you can see, we are still keeping busy, still at it. And I'd also like to give a quick shout out to one of our volunteers, the one and only Craig, who has been hors de combat for the last couple of weeks, months, due to selling his business. Well, he popped in to see me today, And the good news is he's going to be back in regularly from Monday. So I've got a job all lined up for him, of course. I don't want him standing around scratching his whatsits and doing nothing. So anyway, and so as I said in the last video, if anyone else out there fancies getting involved, give us a shout. We always find work for you. So anyway, folks, that's where we're up to, and that's where we're at. Hope you found it educational, informative as always. Now take care, and I'll see you around.